Here are the molecular models you'll be using. They have colors. Red is oxygen, black is carbon, white is hydrogen. Each one of these pieces represents an atom. This is a hydrogen atom. This is a carbon atom. This, with its bonds, represents a molecule. Molecules have bonds to hold the atoms together. So you've just reacted baking soda with citric acid. In the baking soda, this is the important molecule. It's called bicarbonate. The citric acid has a complicated molecular structure, but all that's important is that it provides H+ ion. So here's a hydrogen. That's all that the citric acid provided. So you've just seen that when citric acid reacts with baking soda, you get a lot of bubbles. That has to be a gas, and gas is made of atoms, molecules. So we're trying to figure out what did these atoms do to make these bubbles of gas. The gas could be oxygen, O2. This is a model for that. So I'm hoping you see that here we have the atoms that can make O2. There's 1, 2, 3 oxygen atoms, so maybe 2 of these come out and make the bubbles of gas. But we also need to say what's left over. That has to be a reasonable molecule. So I'll show you how we can turn this into O2 plus something else. And to do that, we need to start rearranging the bonds. So I can see I kind of have all the pieces I need right here. If I steal this oxygen atom and this oxygen atom with its 2 bonds, then I can make this structure, which is just like the picture. I have made O2 gas right here. This leftover is important. This has to be part of it. It's a reactant. We don't get the reaction happening until the H+ meets this. The reason being, this carbon is going to need 4 bonds. So you can kind of see I've got a problem here. I only have 3 atoms. Even if I rearrange this, I don't have an atom for the 4th bond. So this is where I go to the kit. This is where I go to the kit and say, time for a double bond. So you can replace these 2 straight pegs, keep the oxygen atom, and use a double bond, which is 2 of these blue curved pegs, to link the oxygen and carbon. So there's 2 molecules, one of them being O2, and the other being all the other atoms bonded together in a way that gives the carbon 4 bonds. That's essential. So this is what you take a photo of, showing the possibility of making O2 gas from those original reactants.
Here's where you put that photo for C, molecular structures you formed. 2 molecules. Put your picture right here.
Once you've done that, you really should go back to the original molecules. You have a photo, what they look like. Requires you to rearrange some bonds, so be patient, do it right.
To do this, I'm taking away the double bond, replacing with some single bonds. The straight pegs are single bonds. And I'm trying to get back to the bicarbonate ion. All the oxygens are bonded to the carbon, with 1 hydrogen there, the other hydrogen free.
This is what you started with. Go back to the beginning, then you can try to say, I can make a different gas out of these same atoms, these same reactants. That's the challenge that you're facing.
So if you've been following along, possible reaction number 1 is done. But then below that is possible reaction number 2, where you make hydrogen gas, starting with these same molecules, make something different. And possible reaction number 3, make CO2 gas.